Chapter.
The name of the chapter is Combustion and Flame.
Yes.
No, this we have not done. We have done only coal and petroleum till chapter number 5.
Okay, this is Sufyan talking, right?
Yes, ma'am.
Yes.
Are you sure, Sahil, others? Tell me from where we have to begin.
Chapter number 6.
Chapter number
Chapter number
6.
6. I'm revision करा दो.
Chalo, ठीक है. So we are starting from chapter number 6, okay?
Okay.
Can
Yes.
anybody read?
Yes, ma'am. We
Yes,
use
please go
different
ahead.
kinds of fuel for various purposes at home, in industry, and for running automobiles. Can you name a few fuels used in our homes? Name a new few fuels used in trade and industry. What fuels are used for running automobiles? Your list will contain fuel like cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas, etc. You are familiar with the burning of a candle. What is the difference between the burning of a candle and the burning of a fuel like coal? Maybe you were able to guess right. Candle burns with a flame, whereas coal does not. Similarly, you will find many other materials burning without a flame. Let us study the chemical process of burning and the types of flame produced during this process.
Okay. So what they are talking about is they use different kind of fuel for various purposes at home. We use fuel at home. We use fuels in industry for running automobiles. What are automobiles? What are
Vehicle.
automobiles? Yes, correct. So we need fuel for that, right? Can you name a fuel used for automobile?
Yes. CNG, petrol, diesel.
Very good. Okay. And at home also we use fuels such as kerosene, right or not?
Yes. Kerosene, LPG, coal.
Yes, correct. So you are familiar with the burning of a candle. What is the difference between burning of a candle and burning of a fuel like coal? We know that candle burns with a flame. We can see the flame,
Yes.
whereas coal does not burn with a flame. It just glows, right?
Yes.
So that is the difference between burning of a candle and burning of a coal. And here we are going to study the chemical process of burning and the types of flame produced during this process. We will go through burning, what happens in burning, what chemical activities are done in while we are burning something, and also we will be studying types of flames. Okay, let's move on to combustion. If anybody wants to read, let me know. Okay.
Okay. What is combustion? Recall the activity of burning of magnesium ribbon performed in class 6th. We
Seven.
learned 7th.
Seven, beta.
7. We learned that magnesium burns to form magnesium oxide and produces heat and light. We can perform a similar activity with a piece of charcoal. Hold a piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. What do you observe? We find that charcoal burns in air. We know that coal too burns in air, producing carbon dioxide, heat, and light.
Okay, you have already studied the activity of burning of a magnesium ribbon. What do you do that? First, we take a magnesium ribbon
Burn it.
and rub it with a charcoal. We are rubbing that magnesium ribbon with a charcoal, right?
Yes.
And when we burn magnesium, we are burning it in the presence of air, correct or not?
Yes.
So the
Oxygen.
oxygen present in air reacts with magnesium and forms magnesium
Magnesium oxide.
oxide, correct. हैंड राइटिंग समझ में आ रहा है बेटा?
Yes. Yes.
Okay. Okay. So we can perform similar activity with a piece of charcoal. We can do the same thing with a piece of charcoal. What you need to do is take a pair of tongs, hold the piece of charcoal, and bring near the flame of a candle or a Bunsen burner. Do you know what is a Bunsen burner?
Yes, I have
Do you?
seen it
Yes, you must have seen it. Seen it in where have you seen it?
in
Where
the
did you
lab.
see?
Lab.
Correct. Correct. So that is the Bunsen burner. It looks something like this.
Yes.
Yes or no?
Yes, ma'am. As it
And this
serves
is the
over.
wire it is connected to, right? This is something of a Bunsen burner. Okay. We find that charcoal burns in air. Charcoal only burns in the presence of air, and we know that coal too burns in air producing carbon dioxide. Coal also burns in air which produces carbon dioxide, heat and light. Okay? What do coal produce when we heat it?
But
When we heat coal, this is the
carbon
symbol of
dioxide.
heating. It produces carbon dioxide, heat
And
and
light.
light. This is the symbol of heat, okay?
Yes.
Okay, understood everybody?
Yes.
And the picture here shows the burning of a magnesium ribbon. Go ahead, chalo.
A chemical process in which a substance reacts with oxygen to give off heat is called combustion. A substance that undergoes combustion is said to be combustible. It is also called a fuel. A fuel may be solid, liquid, or gas. Sometimes light is also given off during combustion, either as a flame or as a glow. In the reactions mentioned above, magnesium and charcoal are combustible substances.
Okay, so a chemical process in which a substance reacts with oxygen to give off heat is called combustion. Whenever we are burning something and that substance, if it reacts with oxygen which is present in air and it gives heat, it is called combustion. Okay, that process is called combustion, and the substances which undergo combustion are said to be combustible substances. Understood what is combustion? Anything that
Yes.
reacts with air and gives off heat is called combustion. A chemical process in which the substance reacts with oxygen. कोई भी substance ले लो और अगर वो oxygen के साथ react करता है and it gives off heat, it is called combustion. And the substances that undergo combustion are known as combustible substances. We can also call them fuel. Okay, fuel can be solid, it can be liquid, or it can be in gaseous form. And sometimes light is also given off during combustion. When we are burning something, it glows, right? So along with heat, it also produces light, either as a flame or as a glow. It can be in the form of flame or it can be in the form of glow. While we are burning the candle, it gives off flame. But while we are burning coal, it glows. Okay. Yes or no?
Yes.
All right.
Yes.
Let's move ahead. Read activity 6.1 beta.
Collect some materials like straw, mastic, kerosene oil, paper, iron nails, stone pieces, glass, etc. under the supervision of your teacher. Try to burn each of these materials one by one. If combustion takes place, mark the material combustible. Otherwise, mark it as non-combustible.
Okay. You have to collect some materials like straw, matchstick, kerosene oil, paper, iron nails, some pieces, stone pieces, and glasses. And you have to try to burn each of these materials. And if the substance is burning, you can call it combustible. And if not, you can call it non combustible. Can you tell me wood? What about wood?
Combustible. Combustible.
Combustible. What about paper?
Combustible.
Iron nail.
Non-combustible.
Kerosene oil.
Combustible.
Stone piece.
Non-combustible.
Straw.
Combustible.
Charcoal.
Combustible.
Matchstick.
Combustible. And
And
glass
glass.
non-combustible.
Okay. Others are not present in the meeting. Why is only what's your name, beta?
And Sheikh Sahil.
Ma'am, I
Sheikh
read.
Sahil. Yes, beta, go ahead.
Can you name some more substances which are combustible? You can add those to table 6.1. Let us investigate conditions under which combustion takes place.
Okay. Read activity 6.2. We will be seeing what is combustible and in what conditions the substances can burn. Okay. That is activity 6.2. Read, beta. What's your name?
Ali Reza.
Ali Raza. Surname?
Question Vasaya. Question be
Vasaya Ali Raza.
yes. Question be careful while handling burning candle. Fix a lightly candle on a table. Put a glass shimmy over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Figure 6.2a. Observe that what happens to the flame. Now remove the blocks and let the chimney rest on the table. 6.2b. Again observe the flame. Finally put a glass plate over the chimney. Figure 6.2c. Watch the flame again. What happens in the three cases? Does the flame flicker off? Does it flicker and give smoke? Does it burn unaffected? Can you infer anything at all about the role played by air in the process of burning?
Okay, what you have to do in this activity is, let me explain better, then you can read, okay? What you have to do in this activity is, first you take a burning candle and place a chimney on the wooden blocks. Can you see wooden blocks in the first figure? These are wooden blocks, okay? And you have to place the chimney on the wooden blocks. The air is going to enter under the chimney, and that's why the candle is burning properly. Yes or no? There is
Yes.
space for air entering into the chimney, and so the candle is burning well, right? Then in figure B, what did they do? They removed the wooden blocks and the chimney was placed on the wood, on the platform, and there was no place for air to go inside the chimney. And then what happened? The candle started burning with smoke. Can you see it? Correct? In the third case, what happened? That there is no space for air to enter the chimney from below, as well as the wooden block is placed on top of the chimney also. So there is no place for air to enter from above also. So what happened? Slowly and gradually, the candle flame flickered off. It went away. Okay, understood?
Yes.
So what
Yes.
what can we conclude from this activity? That air is necessary for combustion. We need air if we want to burn something. Yes or no?
Yes.
Correct. All right. What happened in the first case? I'm repeating it once again. If you do not understand, please listen carefully this time. All right. First, in first figure, what happened? They placed a burning candle and the chimney was placed on the wooden blocks. So there was place for air to enter from below the chimney, and that's why the candle was burning properly. Then what happened? That they removed the wooden blocks in figure B and the chimney was placed on the wooden platform. So there was no place for air to enter into the chimney. So the flame started burning with smoke. It was producing a lot of smoke. In the third case, what happened that they placed the wooden block on top of the chimney as well. So there was no place from below the chimney for air to enter the chimney from down, as well as it did not have place to enter in for air to enter the chimney from above also. So the candle flickered off, it went away. Okay, so what does it prove? It proves that air is necessary for combustion. जैसे air जा रही है, candle is flickering off, right?
Yes.
Understood? Can you explain it? Sahil, can you
Yes,
explain it
ma'am.
better? Yes, beta, go ahead. Yes, Sahil, go ahead, beta.
Yes, ma'am. We find that for combustion air is necessary. The candle burns freely in case when air can enter the chimney from below in case B. When air does not enter the chimney from below, the flame flickers and produces smoke. In case C, the flame finally goes off because the air is not available.
Hmm, correct. Who else can explain it? Who else can explain? Anybody else? Saya, Yasgar? Yes, are you there in the meeting?
Yes, ma'am.
Yes, beta, come on, explain. Explain the activity. Yes, I'm waiting for you, beta. Do you want me to repeat it for you?
Yes, ma'am.
Will you explain it after that? Yes or no?
No.
Why not? You want to explain it in Hindi if you're not comfortable with English? You understood or you did not understand? You want me to explain it again?
Last step,
Huh?
not understood.
Last step not understood. What happened? First, the chimney was placed on the wooden block in the first figure. Can you see it here?
Yes.
Then the wooden blocks were removed. So there was no place for air to enter the chimney. क्योंकि wooden block नीचे से हटा लिए और chimney was kept on the platform, correct?
Yes.
So there was no place for air to enter the chimney, right? नीचे से air नहीं जा सकती थी chimney के अंदर, है ना?
हाँ.
Third figure, what happened in the third figure? They placed a wooden block above the chimney also. So air could not enter from above also, and air did not enter from below also. So the flame flickered off, it went away because there was no air, so candle could not burn. Correct?
Yes. Now understood.
Understood? Can you
Yes.
explain it?
Yes.
Okay, go ahead.
Chimney is burning then because of brick. Then brick is taking chimney go away.
Chimney did not go away, beta. Flame went away.
Go away.
Hmm.
In upper side and below side, no air is coming because of
Because
brick.
of that? Yes, because of the brick. Yes, correct.
Then it's gone.
Okay. Chalo, who is reading now?
I'm
Who
Sahil.
wants to read? Yeah. Sunraj Mahida. Okay, yes, beta. Come on, read.
Ma'am, this activity 6.3,
हाँ जी.
Activity 6.3. Place a pieces of burning wood or charcoal on an iron plate of tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does charcoal stop burning after some time? Can you think of the reason why it stops burning?
Hmm. Read ahead.
Okay. You might have heard that when the clothes of a person catch fire, the person now recalls some of your experiences,
The person is covered with a blanket.
covered with a blanket to extinguish fire. Can you guess why?
Okay. What they are telling us is in activity 6.3, they are asking us you have to place a piece of burning wood or a charcoal on an iron plate or tawa. What you have to do? You have to place a piece of burning wood or a charcoal. Okay. तवे पे लकड़ी जली हुई लकड़ी को रखना है and then you have to cover it with a glass jar or a tumbler or a transparent plastic jar. And what happens? Does this charcoal stop burning? The charcoal is going to stop burning if we place it on a place a glass jar on it because then the air cannot enter and that's why the charcoal piece or a piece of wood will stop burning. Okay. Then also you might have learned that when a person is burning, we cover him with a blanket to stop the fire. Yes, control the flame. Yes or no?
Yes, it is because
Yeah,
the
correct.
air could not enter and the fire extinguished.
Very good. Okay, the air will not be able to enter inside because of the blanket, and that's how we can take control over the flames, right? Go
Yes,
ahead and read. Sunraj is only reading.
Yes,
yes,
I
ma'am.
read it.
Simraj was reading.
Yes, Sunraj, read better.
Now recall some of your experiences. Does a matchstick burn by itself? How does it burn? You must have had an experience of burning a piece of paper. Does it burn when a burning matchstick is brought near it? Can you burn a piece of wood by bringing a lighted matchstick near it? Why do you have to use paper or kerosene oil to start fire in wood or coal? Have you heard of forest fires? Forest fires?
Read this paragraph with me, then we'll go ahead, okay?
Do this, then this, do this experience.
हाँ हाँ बेटा हाँ.
Do these experiences tell you that different substances catch fire at different temperatures? The lowest temperature at which a substance catches fire is called its ig- ignition
Ignition.
temperature. Ignition temperature. Can you tell now why a matchstick does not catch fire on its own at room temperature? Why does the matchstick start burning on rubbing it on the side of the matchbox?
Okay. So what they are talking about is we will recall some of our experiences and you will know that does a matchstick burn by itself? How does it burn? Matchstick अपने आप जल जाती है ऐसे पड़े पड़े. We need to rub it, right? To ignite it. Yes or no? We are
Yes,
talking about matchstick here. Okay. And you also know that burning a piece of paper. Does it burn when a burning matchstick is brought near it? It will only and only burn when burning matchstick is brought near it. And can you burn a piece of wood by bringing a lighted matchstick near it? Can you burn a piece of wood with that? No. So why do you have to use the paper or kerosene oil to start the fire in the wood? So if you want to put the wood on fire, we need kerosene oil and a lot of paper to burn it. It will not burn just with the help of a matchstick, yes or no? And what are forest fires? Can anybody tell me what are forest fires?
It is a natural disaster.
It is a natural disaster. How does it happen?
The branches of the forest rub with each other, and the friction creates the heat, and because of the heat, the,
Because
the
of the
wood
heat,
starts
what
burning.
happens? Yes, also when there is a lot of heat, it happens during summer. When there is a lot of heat, the dry leaves start catching fire and slowly they start spreading, and the whole forest is on fire gradually when you see it.
Yes,
It starts from the dry grasses, okay? The dry grasses start burning because of a lot of heat of the sun, and then the fire moves ahead. It spreads till the bushes, then the trees, and that's how the whole forest is on fire, correct? So now, do these experiences tell you that different substances catch fire at different temperature? Not all substances catch fire at same temperature. They need different temperature. So the lowest temperature, कम से कम टेम्परेचर जो किसी भी चीज को जलाने के लिए नेसेसरी है, वो टेम्परेचर को we call it ignition temperature. The lowest temperature at which the substance catches fire is called the ignition temperature. Yeah, understood what is ignition temperature? कम से कम
yes,
टेम्परेचर जिससे कोई भी चीज जल सकती है उसको कहते हैं ignition temperature. Understood? So now we know that why the matchstick does not burn on itself. Because when we rub it, we increase the temperature of a matchstick and that's when it will catch fire. Correct?
yes,
Yes. Now we will be seeing the history of a matchstick, which is very important. I will explain you right here, right now. Nobody needs to read it, okay? So what happened? The history of matchstick is very full. बहुत पुरानी है ये matchstick की history. More than 5,000 years ago, small pieces of pine wood were dipped in sulfur and they were used as matchstick. Pine wood, pine wood is a type of wood, and the small pieces were dipped in sulfur and they were used as matchstick in ancient Egypt. Okay, they were used as matchstick. What was used? Pine wood dipped in sulfur, correct? But then what happened? Then the modern safety match was developed only about 200 years ago. Right? 200 years ago पुरानी बात है. And that was the time when modern safety match was developed. What happened in that? The mixture of antimony is a substance, okay? It is an element, and antimony trisulfide was used along with potassium chlorate and white phosphorus. Potassium chlorate and white phosphorus with some glue and starch. Okay, along with glue and starch was applied on the head of the match. वो ऊपर जो ब्लैक कलर का होता है ना इसमें ये सारी चीजें होती है एंटीमनी ट्राइसल्फाइड पोटेशियम क्लोरेट व्हाइट phosphorus and with some glue and starch. Okay, it was used as a head of the match. Then,
yes,
when struck against a rough surface, when we rubbed it against a rough surface, white phosphorus was ignited due to the heat of friction. रब करने से friction होता है, friction से वो जल जाता था. क्या? White phosphorus started burning. So this started the combustion of a match. That's how the combustion of match was started. But फिर क्या हुआ? White phosphorus was proved to be very dangerous for our health. जो लोग वो ये मैच स्टिक बनाते थे उसकी हेल्थ के लिए भी हार्मफुल था और जो लोग ये मैच स्टिक यूज करते थे उसकी हेल्थ के लिए भी व्हाइट फॉस्फोरस वाज harmful. Then what happened? Then what did they do? These days, the head of the safety match contains only antimony. Now,
red,
the head Head of the match contains only antimony trisulfide and potassium chlorate. Only two things are used now in the head of the matchstick because white phosphorus was banned for using it in the matchstick. The rubbing surface मतलब जो मैच बॉक्स पे होता है, it had powdered glass and a little red phosphorus. White phosphorus is not used now, red phosphorus is used. That's why the मैच बॉक्स की जो रफ सरफेस होती है जिसपे हम मैच स्टिक को रब करते हैं वो रेड कलर का होता है. Okay, and when the match is struck against the rubbing surface, the red phosphorus is converted into white phosphorus, and immediately reaction with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide. तो रेड phosphorus जो है वो white phosphorus में convert हो जाएगा, which is less dangerous. The red is converted into white phosphorus. Okay, and immediately react with potassium chlorate. It will start reacting with potassium chlorate in the matchstick head, and then it will ignite antimony trisulfide. तो पहले white phosphorus use होता था matchstick में, but it was proved to be harmful for the users as well as जो लोग उसे बना रहे थे उसके लिए harmful था, तो white phosphorus ban कर दिया. Then the head of the matchstick was only made with antimony trisulfide and potassium chlorate. Only two things. Okay, two things. And the rubbing surface जो मैच बॉक्स पे जो rubbing surface है उसे powdered glass और red phosphorus से बनाया गया था. And when we used to strike the matchstick, the red phosphorus got converted into white phosphorus, and that react with potassium chlorate, and it was enough to produce enough heat to ignite antimony trisulfide, and that's how the flame was produced. Okay, understood?
Yes,
Yes,
Is it easy for you, or should I explain it
yes,
again?
ma'am.
yes, understood.
Pakka?
Yes,
Yes,
Okay. Chalo. Who wants to read now? Are you enjoying beta?
yes, ma'am.
Okay, chalo. Go ahead. Read. Who wants to read now? Should I call out the names? Azil Gogoda.
मैं करूँ फिर से.
I cannot hear you, beta. Can you speak
we
louder?
never
Can you
I'll
speak.
listen?
do once more.
What's your name?
Samrat.
Azil.
Sanraj.
Azil.
Uh,
Fazil. Okay,
okay,
Sanraj, I'll let you read after some time.
okay.
You read, beta. Azil.
I'm reading.
Okay.
What?
Okay, ma'am.
हाँ जी करो चलो.
We find it up. Ma'am, yeah, saying na we find data.
Yes, yes, beta, yes.
We find that a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature.
Ignition
Have you
temperature.
ever ignition temperature? Have you ever seen cooking oil catching fire when a firing pan is kept for long on a burnt stove? Kerosene oil and wood do not catch fire on their own at room temperature, but if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of wood, that we need to take special care in storing kerosene oil? The following activity shows that it is essential for a substance to reach ignition temperature to burn.
Okay. Okay, we shall end the lecture here and I'll see you tomorrow. Okay.
Ma'am,
Okay,
what? Please repeat again.
We end the lecture here and I'll see you tomorrow. Okay.
Okay, ma'am.
okay,
Bye
ma'am.
bye. Bye.
Bye.
Bye.